So, welcome everyone again. This is the our last session for the day. Uh, we have Uwe Ricken from Germany. He's a Microsoft certified master, and we've had sessions with him in our user group. So you pretty much know his work and his sessions. Uh, he'll be talking about daily index performance problems and how you can address them. So I'm gonna hand it over to Uwe to start the session.
Okay.
Oh,
Yeah, thank you very much.
one question: Do you want me to interrupt you when there's a question on the chat, or do you want me to wait for it at the end of the session?
Yeah, you can interrupt me immediately, no problem, because when it belongs to the demo I'm doing, then I'm pretty fine with it. I think it's way better to answer the question that moment when I'm doing the demo. Yeah.
All right, then that's what I'll do. All right, I'll hand it to Uwe then.
Okay. Yeah, thank you very much. And yeah, thank you that I could have the chance again to speak to the Singapore user group, SQL Server user group. Singapore is my absolutely favorite all around the world. I'm quite often in Singapore. Unfortunately, this year it didn't happen. So we have to go virtual, but I hope that you enjoyed so far the SQL Saturday as it is. And I know that in your time zone, it's nearby afternoon. Here, I drink my first coffee and I'm totally awake and I'm so happy to present now. I'm presenting about daily index and performance problems, which I have lots of demos for. So this session is pure demos, lots of demos. So thank you again, first of all, for all the sponsors of the SQL Saturday. I think everybody of you know that without sponsors, these kind of events won't happen. So we have global sponsors and we have local sponsors. It's useless to tell you, please visit their booths. It doesn't make sense today. Okay, here we are. This is me. My name is Uwe Ricken and I'm from Germany, as you heard in the introduction. I'm a SQL Server master and an MVP, and I enjoy working with SQL Server, and I hope that you will see this in the next slides. So this is our agenda. This is a full agenda for approximately 2-3 hours, so we cannot handle really everything, but I truly hope that we can get at least to the 4th or 5th demo here. I will talk about problems with partition views, is null and searchable queries. That is wide open problem I see when I am working with my customers. Correct data types for predicates, really important, and simplification by using foreign key constraints. Let's see how far we can come. First thing, by the way, all these scenarios I want to show you and all the demos, what I'm showing to you, are coming from my true experiences with real customers. The only thing what I did, I was strongly simplifying that. And here is the first scenario. I was at a company who didn't have at that time an enterprise edition of SQL Server. Maybe you know that before 2016, partitioning was an enterprise feature. So what they did then in this scenario was they had a big table, billions of rows in it. And what they did was they were separating the orders by year. So for every single year, they created a new table, and then all the rows went into this tables. Afterwards, the developer team had created a so-called partition view. This is the object where all the tables, where we can get access to all the other tables underlined. So here you see in this picture the situation. We have in our demo database lots of tables, and for every single year we have the same table separated. And let me show you what problem you might deal with when you are going with partition views. So here it is. Here I start with this. What I'm doing is I'm creating a demo database, and within this database I will now create for every single year from a source table which has 3 million rows, separate tables. So it's up and running. And here in my demo database, let me refresh this. It takes a little bit to go 3 million rows. It's early in the morning. My computer is not as fresh as I am, so it takes a little bit. But when the 3 million rows have been inserted, you can see this here in the tables. Go for it. See how far it is. So here are my separated tables. For every single year, we have one. So now you are in the situation as a developer, you want to have an access layer where you can make sure that you access really all tables. It doesn't make sense to put in your applications, oh, come on, when it is year 2000, then access orders 2000. When it is year 2019, then access orders 2019. So for that purposes, we create a view called all orders. And what I'm doing in this view is very simple. What I'm doing is I run a select for every single table with a union all in it. That makes sure that we get all the tables here. So it's, you see, it's many years, 20 years of experience for this customer. And here comes the problems. First recommendation for all of you who are developers, whenever you test your queries, whenever you want to improve your queries, make sure that you can measure it. And with measuring, I mean that you put the statistics, I/O, and time on. That gives you the information, how many CPU do you consume and how many I/O you will produce with the query. Here is my query, very simple. I want to have all the orders from January 2014. So I run this query with the execution plan, and you see it takes a while. Also, the data are in the cache. And you see here I have 5,241 rows. It took 4 seconds for the query. You might think, hey, come on, 3 million rows, 4 seconds, incredible fast, maybe. Let's have a look first of all to the I/O statistics. What I can see here is a nightmare because I see that every single table gets touched. The biggest problem is we're going in parallel, and you see from the logical reads, which are the pages, what SQL Server is reading, we have hundreds or tens of thousands of pages. And that is truly a nightmare for performance. And here you see the CPU consumption. And what makes me a little bit nervous is that most of the time for the execution of the query, it's using CPU. So this is the fact what we don't want to have here. When you look into the execution plan, then you can clearly see what the problem is. Also, I'm just only running a query for a dedicated year. SQL Server has to touch every single table. And this is not all. I give you one more. If I look to the separate table here, I see that they are using a predicate, but that is clear because my queries do not have any index. So the first thing what I'm doing now is I know that the queries are mostly running against the order date. So just only for simplification, I put a clustered index on my order date, and that I do for every single table. This is quite fast, go for it. So now I make SQL Server, I make the tables, the heaps, a clustered index on my search predicate. So while it's running the index build, I go back to my query. So my expectation now is that I have a wonderful running query, a perfect running query, because I have my index on the order date. It's strongly limited to only 5,000 rows. And now I should hit new speed records. I run this query, go for it. And yay, it's way faster from 4 seconds to just only 1 second. We are so happy about that. And when I look to the I/O statistics, I see it could be a little bit better. For what reason? The first thing is, I see here's my 2014, and it seems to be that the access pattern is perfect here because I do only a few I/Os on this 2014 table. But the drawback I have here is that I, again, have to touch every single table. And this is not the way I want to do that. Think about the following situation. What will happen if someone is running an update on the 2019 table and you want to read data from 2014? At that moment, you have to wait, because if there is an X log on a row which you want to access, you have to wait for it. Concurrency. And when we look into the execution plan, you can see again the problem we have here. Every single table gets touched. The only difference we have here is we do not need a push down predicates or filter predicate, but we are using a seek predicate. What means that we are slightly more performant than we did before. And here is my 2014, 2011, 12, 14. Here we are. And here you can see that the seek predicate is focusing just only on the January. So what can we do? We have two possibilities. The first one is that we will do the separation inside the view. That means that you take a where clause in the view. You do not say select star from orders 2000 union, select star from orders 2001. This is one thing what you can do, but I am more a fan of assisting the query optimizer. Give the optimizer a few more hints that the optimizer knows by itself. Hey, come on, there cannot be any other dates than, let's say, for the orders 2000, than orders from the year 2000. And you have a tool in SQL Server which do that for you. And this tool is called a constraint. And you all the developers know this. You can limit the input for a column by using a check constraint. And that's what I'm doing here. You see here that I will now go for every single table and say, for 2000, for example, make a check constraint on the order date for the year 2000, or for the 1st of January 2000, and the order date has to be lower than 2001. And this, I go with a loop for every single year. Let's do this. Go for it. That's not very long. And here is my query again. And see what happens now. First of all, again, the same query for 2014. We get our 5,000 rows back. Have a look to the IO. And this is what I want to have. You see here that I have my orders table, just only this order table. No other table gets touched. And the cool thing here is, look to the CPU consumption. It's just only 31 milliseconds instead of 800. So we had a dramatic improvement with this query. And you can see it in the execution plan in the same way. We just only touch the affected table. And that's what we want to have. And if now someone is doing some changes in the 2019 or 2018 table, we don't have to worry about it, because when we run a query against 2014 or any other year which is not affected by an update, we can run this query without any problems. If you have more than one table you need to touch, here I say give me for December 2013 and January 2014, SQL Server will know that there can only be two tables which contain the data. And I look into the messages and I see, perfect, yes, 2013 and 2014, and my execution plan shows exactly that. The last optimization, maybe you didn't see it on the first view, the last optimization I have here is, before I had these indexes in and the check constraints in, SQL Server was using a parallel execution plan, so I use way more CPUs than I truly need to do. So this is something what I can strongly recommend if you're dealing with big data, and in modern times, I don't see tables with a few data only or small databases. I have customers which have databases with billions of rows in it in a 15 terabyte data. So here comes the solution. Use check constraints on the attributes which are containing the segregation values. For a data switch, you have to add a new table, change the view, and add new constraints to it. So it's a little bit work to do. If you have Enterprise Edition, or you have the luck to have at least SQL Server 2016 Service Pack 1, then you should use partitioning, because partition views is nothing else as partitioning. So if you have application or have a SQL Server before 2016, then unfortunately for partitioning, you need to have Enterprise Edition. But hopefully you all have at least 2016. Okay, this is the first problem, real world problem I was dealing with. And here comes the second one. And by the way, I took it as a third demo, at the second demo, because I see it so often that developers will use functions in a predicate. Is null is a SQL Server function, and searchable predicates does mean that SQL Server is able to look in an index for a predicate. Search stands for search argumentable predicates. I will show it in the demo in the next few minutes. So here comes the scenario. A developer had a production table and they were suffering from performance problems. So what he did then was, don't do this, by the way, he was creating a test table in the production database, yeah, but he took the same data, but he was not thinking of the metadata information. So he saw the table and then he created another one, but he was not looking at some tiny specifics what this production table had. So he was analyzing the query, and then he was seeing that there is an index required. He put it on the test table, it went perfect, but when he implemented it in the production table, he was suffering from the performance degradation. It didn't improve the query. Here comes this scenario. By the way, it's a funny one, and to be honest, you might think, or a few of you might think, come on, I know what it is, but keep in mind, I see it so often. I would say every third customer, we have this problem. So I create again my demo database, and here is my production table, what I'm creating. It's my customer orders. I give it the extension prod that you can see the difference, and please have a look to the invoice number. The invoice number is allowed to be nullable. So it can be that we have empty invoice numbers. Then here is the table created by the developer. And you see immediately the difference. The invoice number in the test table is not allowed to have nullable values. Good. So what I'm doing now is, it takes a little bit because we have to insert 3 million rows. I fill my production table with 3 million rows, and then I take accidentally 1,000 rows, which I make the invoice number a null or this specific date, and then I put all these data into the test table. So this takes a little bit, and afterwards, when the query was running, I want to check how many rows do we have in the production table and how many rows do we have in the test table. And I promise you, they are absolutely identically, because I make sure that I take the production data and put them into the test table. So come on, my little laptop. It's early in the morning. Would you like to have a coffee? Yeah. So, but I think when I give him a coffee, then the session will end immediately. So now, come on. So it's done. Here are my data. And you can see, yeah, we have 3 million rows in every single table. Perfect. And again, every developer should do that. Make sure that you run your statistics, I/O, and the CPU. Here is the query from what the developer has seen in the production system. And this query is using the isNull function, which tells me, okay, if the invoice number is empty, use the substitute the 31st of December 9099. And we run this query in the test environment. We have a look to the messages and we see, oh my goodness, yeah, we have way more I/O than we truly need. Because we have just only 1,000 rows to get. If we look into the execution plan, we can see, okay, it doesn't look good because we do a full clustered index scan. What you can see here, have a look to the push down predicate here. The predicate does not use the is null, okay? But so the developer is creating a non-clustered index on the invoice number in the test table. And then he takes exactly the same query again and runs this query. Okay, here we are. It was fast. By the way, when I look into the messages, I see that I have reduced my logical reads by nearby the half. Oh, sorry, not a half. It's only 5%. And what I see is that my parallelism, my parallel query plan has moved to a single-threaded plan. And here is the result. And the developers say, hey, I'm so happy. That's what I wanted to have. My query is running perfect. So what will he do? He's raising a change ticket and then say, please implement this index in the production table. So he's doing that. And now he is going for getting a coffee. He's going in the kitchen for getting a coffee. And he was thinking that now all the business will pray to him and say, oh yeah, you did it so wonderful. You're our hero. And they run the query. And oops, it took a second. When we go to the I/O, we see this. Say, oh, nothing has changed. What was going on here? I tested it and everything was perfect. But here you can see that we go in parallel again, and the I/Os were not 3,000 as expected. No, it was 10,000. We look to the execution plan and we see what the problem is. What SQL Server is doing here, it's not seeking in my index. No, it's using a push down predicate. You see it here in the properties that the predicate is using the is null. And then we come back with these 5,000 rows, and then we go with this 1,000 rows, and then we go for every row into the key lookup to get the other attributes of the table. This is so weird. What is the problem here? Well, the problem is definitely the difference in the nullable column. And in the test system, we decided not to have null values in the invoice number, but in the production system, it was. We cannot change the metadata here. So what SQL Server then needs to do in the production system, it has to go and check for every single invoice number. Hey, are you null? Then take this substitute. In the test environment, we didn't have to do that because the query optimizer knew a command that cannot be that there will be any nullable rows in this table. So the query optimizer knew that, and then it was eliminating the non-searchable predicate here from the test environment. What can you do to use this index? This is the big question here. The condition is we cannot change the production table. We cannot do a alter table, alter column, it's not null. That doesn't make sense. So what we need to do then is we need to make sure that the query is running perfect. And here we go for a solution that SQL Server can use the index properly. So you see that in the production system, it didn't work. And when I compare, I don't need to compare it. Here is the solution for the production system. If you have an is null function, it is exactly the same as when you say, give me the rows where the invoice number is null or the invoice number is like this. That's exactly the same. But now see the big difference. We don't put the column into a function which transforms the value or has to recalculate a new value. Now, when I look to this, we know that this is searchable, search argumentable. Look for invoice number equal to, or look for invoice number which is empty. And when I run this query, I have not a perfect, but I have a good plan here. It looks complicated, but it isn't. Long story short, the is null and my substitute is they're putting into a system internal table where we get back two rows. One for the value for is null and one for the value for the substitute. Then with these two possible values, we go now into an index seek here. And you can see here that we do not have anymore a pushdown predicate, but we have a seek predicate here. And that's exactly what we wanted to have. So we come back with our 1,000 rows, and then we go and look for the additional columns. That's one of the tricks. If you say, oh my goodness, this execution plan looks absolutely weird. And it could be that the developer would say, too much operators. If I get through all them, I get lost. Make it a little bit easier. A or statement, an or predicate is exactly the same as this construction here. What I'm doing is I make internally two queries, say, give me all the orders where the invoice number is null, and put them together with all the orders where the invoice number is 9991231. I run this query and see what SQL Server is doing now. Maybe for you as a developer, this execution plan is easier to understand. What we're doing is we're going through this one here and say, give me that one which is null, which is no, and look for the additional columns, and then go and look for my substitute. And we come back with 1,000 rows, and we go for a key lookup to get the additional rows. So the only difference here is that we have to touch our customer orders table 2 times. But that's the trick here. So, and what you can do too is this one here. Use and exist with a union in the subquery. I run this query, take the execution plan, and here is my subquery. It comes back with 2 rows. We go to the index seek operator for the invoice number, and the rest of the columns get touched by the key lookup. Here we have the point that the customer orders table just only get touched 1 time. What you want to do depends on your preparations. If you say, oh, I think that union is so great, or then do it this way. If you say this is easier for me to understand because this is not so much characters to type, because maybe it can be that you do not can type so fast, you're not secretary, then this may help. But every solution other than this function around a attribute is way better than this function here. So this is the solution. Don't use is null as a search condition for nullable columns. Instead of it, use an or, a union all, or use a subquery. The best practice is to have no attributes which are allowed to be nullable. But okay, we all know this is wishful thinking, but that's not reality. Correct data types of predicates. Oh, yeah. This is some fun here. The correct data types are quite important. And maybe a few of you are developing, let's say, with .NET, with the entity framework, with nhibernate from Java, all this kind of stuff. And I see very, very often, way too often, so that the data types for parameters are not the data types which are stored in the database. So here is the scenario. A new application has been purchased, and the application suffers from performance when searching for customer numbers. The attribute ID is indexed, but the execution plan showed an index scan instead of an index seek. What's going on here? So, yeah, check it out. I go into this one. By the way, you don't have to write everything. I will upload the presentation and all these scripts with the customer database, with the demo database, to the SQLSATSG website that you can download. I again create my demo database, and then I have this table here. This is my customer table. And here you can see we have all with fixed length characters, but it's not Unicode, it's ASCII code here. Come on. And now I fill it with approximately 100,000 rows. I don't like to do tests with small databases or with small amount of data, because then everything looks fast. So let me see how much data we do have here. And what you can see here is that we have data pages 5,770. That means that the data are stored in these rows here. Let me check something. Yeah, okay. So here is the first query. What I'm looking for is I want to have a customer with the ID 10,489. First of all, go to the ID. Look to this. ID is a character attribute, but what the query is doing, it's using an integer here. Integer, numeric. So basically, I would now expect that SQL Server is so intelligent that it say, oh, no, hey, this is the wrong data type. It doesn't fit. So please make the number a character. Let's see what SQL Server is doing. Oh, sorry, I forgot to activate the execution plan. Here is my customer. And when you look to the execution time, you would say, oh yeah, fantastic. The application is working so perfect. The point here is you should not always trust the runtime. As I said, small amount of data will always have short runtimes, or mostly will have short runtimes. If I go to the messages, I see this. And to be honest, if you are looking for just only one dedicated row, do you really want to hit approximately this is megabyte, let me know, 40 megabyte of data for just one row? You might say, well, my computer is fast enough. I have 48 cores in it. It was very cheap, just only $100,000. And yeah, when I pay so much for the CPUs, then the CPUs should work. That could be an opinion. Well, then I would say, perfect. Don't stop optimizing or improve your queries. But what will happen if you have not only 75,000, but you have 75 million rows in it? And then it will definitely scan through your table. So look to this. What SQL Server is doing, it's running a clustered index scan. And this clustered index scan leads to the problem that we have to access everything, to access every single row. And if you look to the properties, you see that we have a push down predicate. And this predicate shows me we have a convert implicit. So that does mean make the ID column in the customer's table an integer before we compare it to the predicate. I mean, that's annoying. And here you see this warning mark, and if you hover your mouse over it, you see the problem or you see the warning. Take these warnings serious, absolutely serious. let me show you what SQL Server is doing. Another recommendation for developers. If you want to make push-down predicates visible, don't do that in production, and don't do it with regular queries, just only for testing, please. You can use this query trace on flag 9130, which makes push-down predicates visible. I run this query again. Here is my result. I look into the execution plan, and here is the point. What we can see here is that SQL Server is pushing 75,000 rows to this filter operator. This is now visible because of this trace flag, and we are coming back with 1 row. Think about the following situation. Here in Germany, it's early in the morning, 9 o'clock, and to be honest, I love to have a coffee in the morning. And what I'm doing then is I'm grabbing my mug, bring it to the coffee machine, press the knob, the coffee is going into the mug, and then I go to the fridge and take a tiny little dose of milk and put it in my coffee, and then I enjoy my morning. This execution plan gives me, for the same situation, I want to have a coffee in the morning, the following work items to do. I stand up in the morning, I grab my coffee, and now I find out that I want to have a little portion of milk. But what I'm doing then is I'm calling the molkerei. I'm calling the what is the name? My goodness! Yeah, the company which ships milk. I don't know the English name currently. And now comes a very funny thing. The company is coming with a truck which contains 75,000 liters of milk. It's shipping this 75,000 liters of milk to you. You are standing in your garden with a cup of coffee, waiting for the milk. The truck is coming. You're entering the truck and you take this tiny little portion of milk, because just only 1 liter out of this truck, and the rest you push into, and the rest is gone. So you have a lot of resources consumed just only for 1 mug of coffee. And that is not what we want to have. So the problem here is exactly this one. The problem is that SQL Server has to convert one of these 2 sites, maybe this or this, to a data type which fits to both. The ID here is a character, and the value we are looking for, this is an integer. And now what I'm doing is I'm going into my internet, and then I'm looking for some very, very interesting information shipped by Microsoft. Precedence of data types in SQL Server. And here, oh yeah, it's in German, but I think it's on English, so here comes it. So, and what you see here is the following. You see in front of every single data type a number. This is the hierarchy. So as lower the number, as higher the hierarchy. I have a character, which is number 28, but the int is on 16, which is higher. So here is the rule. Whenever a data type is in the hierarchy lower, the lower one, then it has to be transformed to the higher data type. The problem with us is here, ours is a character. We are looking for an integer. So the character needs to become an integer. And that happened here. This query is exactly the same as, let me copy this as this one. Both are exactly the same. This one has to be converted because this one is the higher level. The best is that you use the correct data type. When I take this one, because the ID is a character and I'm using a character, then it will work fantastic. Now we have an index seek on it, and you can see that the pushdown predicate is gone, and we now have a seek predicate, and my IO has dramatically decreased. It's just only 3 because of using the index properly. What SQL Server can do for you is, if the data types are, let's say, the same character. Yeah? Character just means, so whether we are using a string, for example, just on a string, then sometimes I see that the entity frameworks are using Unicode variables instead of the true data type. But SQL Server has done many big improvements for that. When I run this one here, it takes 4 IOs, so not a scan, because what SQL Server then is doing, it can convert it. Here you see, this is my, let me put it a bit over. So here is my Unicode data type. This is in the constant. Then it makes the Unicode an ASCII data type. Now we have the same data type here, and we come back with this one row, and this one now can be searched in the index in a proper way, because then we have the same data type. This is working since SQL Server 2016. So if you have 2014, then the behavior is exactly the same as the thing here, what I did with the numeric value. Make sure that you use the correct data types. If you're not sure whether the correct data type is used, you can check it. You check the execution plan for residual predicates. So you have not a seek predicate, but a normal predicate that is an indicator for a push down predicate. Or as a developer, use the trace flag 9130 to make expensive filter or push down operations visible. So you can see here, indexing itself is not the problem. Also, you made the proper index. It didn't work for this solution. Foreign key constraints. Yeah, how shall I do this? So what I see sometimes, not as often as I was expecting, is that the data model, what the developers are using or the vendors are using, do not use foreign key constraints. So that means that they are not following the relational rules, which requires basically a primary key and foreign key relations between the different relations. Many developers are doing it not, and the applications will just only have the tables. And when I ask the developers, hey, why don't you do that? Why are you not using foreign keys? They say, I don't have to do it. My application is controlling that we have the correct data in our tables. This is something where I cannot say, no, that's not true, because when the application is doing that, that's fine. But what the application developers do not consider is that with foreign key constraints, you can help the query optimizer to make queries faster. This is something they do not have on the focus. And let me show you how this is working. Here is the scenario. Developer has implemented 3 tables, and they don't have any foreign key relation in it. So we have in the next demo, we have our customers table here. Then we will have our customer orders, and there is normally a reference. Only a customer can have an order. A valid customer can have an order. And on the other hand, we have our employees table here, because every single order gets handled by an employee. a view is used to access the information from all affected tables. This is a, I would say, a typical behavior what I see very, very often in databases, that nearby almost we try to have views which will cover really everything. And these views are then used by, for example, for reporting or for reporting or for big data queries, all this kind of stuff. And we have all the information in. Sometimes the view is running fast, and sometimes it degrades by millions of %, not only 1,000, because it stops. And let me show you what's going on here and how you can prevent this. This is one of the most funniest things. And that's something what, unfortunately, a few developers do not have on their focus. I create my demo database, and here you see that I'm now inserting creating 3 different tables: my customers table, my customer orders table, and then I run a tiny little update on it because I just only have 150 employees here, and then I add my employees. So in total, we will have here 3 tables. I'm going to refresh. And you see my customers, customer orders, my customers, and my employees. So commit transaction. Okay, it was done. So now, because I read about this, I read about the relational model and said, oh yeah, every table needs to have a primary key. Okay, I do this. I create a primary key on the customers, a primary key on the customer orders, and a primary key on the employees table. Done. Perfect. Here comes the requirement. You will see here a view, order information. And what this view is doing is very, very simple. We want to have the customer ID, the order date, the year, the month, the day, because we want to query it. Then we see the employee ID, the last name, and the first name. Long story short, we have in this view all 3 tables implemented into a relation: customers to customer orders and customer orders to employees. Good. Done. Now, one business guy is running this query. Select customer name and count the number of orders from this customer, from all the customers, lower or equal to 100. Let me show you the execution plan. Here we are. That's fast. Cannot say it's slow. We have a proper index in it. No worries. But you can see here that SQL Server is touching the employees table. It's coming back with 150. Then we go into a hash match and we gather all the orders which are done by these employees. So we have here 3 million rows. We are coming back with them. And then with this few amount of data, what we have here, 100, we are going for every single order into the customers and getting the name of the customer of it. Afterwards, we go into a sort, aggregate them, and we put the data out. Good. We see that we have a problem with this execution plan because we need to scan the customer orders. That is true. That is absolutely a problem. We create this index. So when the index has been created, the developer tests it because people were complaining about the performance. And now it's running brilliant. The employees, the customer orders, and here is my customers, and everything is working wonderful. Yeah, because the query is not going in parallel. First thing. And the second one is that now I use not a full scan on the customer orders, but I'm using a seek predicate. Wonderful. We are dancing, singing loud in our IT department, and everybody is looking around and saying, what is this guy doing? And then he said, yeah, I have a successful story. I was improving a query. We are deploying this. And now the people are running this query, and they sometimes seems to be happy. The big point here is, let's do this. Just put it in, go X. Now I run this query here. Keep in mind, I want to have the name of the customer and the number of the customer orders. Perfect, it's running. So while the developer is happy and he is celebrating, he's maybe having a beer, someone makes an update on just only one row on the employees, and we run this query again. And where is my query? And now complaining starts again. And the problem is that we here have a lock on it. And this lock suffers or makes the degradation here. So I have a view created for me, which give me database locks in a database. And have a look to this. You can see here my query number 61, which is running the update. And here you can see this is the number 53, which is running the select statement. And what you can see here is, and that is quite interesting, both are using the employees table, and both are using the same resource, the same row. And here is the conflict. You can see that the session number 61, this is the update statement, holds an exclusive lock on an employee record. But the second one, which is my select statement, which by the way is always executing here, it wants to have a shared lock on it, but it has to wait. And look for what it is waiting for. This one is the blocking session. And now we come to a very funny conclusion. We say, what the heck is going on? I only want to have the customer and the orders of the customer. Why is SQL Server accessing the employee table? We don't need this table here. The problem is manifested in the view. Because in the view, we say, give the customers, take the orders, take the employees. So the view is executing against all three tables. Why is it doing this? Well, you can say, yeah, because we wrote this. We said we want to have these three tables. But the key point here is that we don't need the employees table here. But the problem is that SQL Server does not know it. You see here it is executing. Keep in mind what happens now. Have a look here, please, to the second window. When I execute this, immediately this one is working. Yeah, now it got executed. Okay, how can we fix it? The key point, what you need to consider here is, and please keep that always in mind, try to help SQL Server Query Optimizer to identify what object it needs or not need. The foreign key constraint, it's not just only because that you know, oh, I can type a few more characters in my code. It has its reason. The reason in the relational model is that we make sure that the detailed table will not contain keys which are not present in the master table. But the query optimizer is very, very, very thankful for that. Absolutely thankful for that, because the query optimizer takes this information to run a so-called simplification against the query. Let me show you what I mean. So you have seen we have blocked this, so nothing could work. So now I'm following the relational rules, relational model rules, and I create now a foreign key first from my customer orders to the customers. Say, okay, make sure that no customer order does have a customer ID stored, which is not present in the customers table. It's done now. Now I do exactly the same with the employees. And as I make sure that every single order will have an employee number which is present in the employees table. That's true, it's going. And now we will have a look to the query again. Here is my query, 100 rows. It seems to be that nothing has changed, the result is the same. When I look into the messages, please have a look to this. SQL Server is using the customers table because we want to see the customer name. And we are using the customer orders table because we want to have the number of orders. But I don't see the employees table here anymore. And if I go to the execution plan, it is exactly that what I have seen formerly in the output. We are scanning, or we are seeking in the customer orders. We are looking for customer IDs lower or equal to 100. And then we come back with that and we join it with the customers. And here we are coming back with 100 rows. And we sort it, aggregated, that the count big operator here, by the way, and we are doing the output here. And this is a really cool thing. Let me do this again. I begin my transaction. I run an update on the employees table, but then I run this query again, and you see nothing can stop your query anymore. And that is so clear because the employees table doesn't get touched in the query. And that is from the improvement of queries side, one of the big benefits you will have when you're dealing with foreign key constraints. So inference of foreign key, the solution is that whether you have indexes or not, indexes might help for improving the I/O and the consumption of CPU, but it will not help you when you have a blocking scenario. So the usage of a foreign key constraint may or will simplify the query. A foreign key constraint will force the query optimizer not to check for references in the join table. And that exactly have you seen here in the demo. A foreign key constraint makes sure that only valid data from the master table or in the detailed table, a check isn't necessary. And that is the point. The good point here, and the very cool thing here is I have more 5 minutes and I can show you another one. Side effects of wrong collation. I hope you enjoyed so far what we are doing here, and I hope that you have seen that you have so tremendous much opportunities to make improvements to the application with indexes and with things which you might think are not dependent on index strategies. Here comes the last one, the side effects of wrong collation. I love this one because that exactly the same problem we have all the time. To the organizers, I'm really sorry if I take 4 or 5 minutes more. Yeah. So here comes the scenario, and this is very, very often. I think if a few of you are DBAs, maybe you have the situation that a new product should come into your a new database application should come, and your question to the vendor was, what collation do you want to have? And then the vendor is looking to you and say, collation? I normally eat meal to dinner. And then what I mean is that he doesn't know what you want from him. And if you hear this kind of answers, be quite careful, because then you can run into these problems here. The point here is, no, I don't want to save this one, but this one and this one not. So side effects of, oh yeah. So the workload, what I want to describe to you here is what I have seen in a big company in Germany. What they are doing is they have a web interface where the key accounts need to pick from a list of open topics, say, I want to deal with this one, and this one, and this one, and this one, and then they went into a basket, and from there, then they can go to every single order, for example. And what the vendor did for that scenario was, in the background, they were creating a temporary table and storing all the key attributes in this temporary table, and then join it so that they can see only the selected rows. And this is something I want to show you here. You see that my TempDB has a database collation, which is Latin 1 general, and this is exactly the same as the server collation. You cannot change it. So now I create a new database called DemoDB, but this one has another a different collation, and here you see the difference. My demo is Latin 1 general bin, and this one is CIIS. Here comes the scenario. In my demo database, I create a table customer orders. I make it cluster key, and then I put 3 million rows into it. Takes a little bit, yeah, I know, because my CPU is burning down here. I don't need the heat. After this, but this is only for demo purposes, I make an index on the order number, because the order number is the key component where they get the data from. Here we are. Let me check the customer orders table, and please have a look from the order number what collation it has. It's the default collation of my database. This is a typical scenario. Here is the workflow. A staff member selects different order numbers from a web page, and the selection goes into a temporary table. This temporary table is used for a join between the orders and the selected order numbers. It's covered in a stored procedure, but I will do it step by step. I create a table, a temporary table selection. In that moment, every single database developer and a DBA should know, alert, 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 because we do not mention the collation. We put in a few data, 100, that's okay, 100 rows. Here we are, and this is this is random. And here is my query, the first query. Look what's going on. I say, please give me every order which I have in my basket, in my temporary table. This query will fail. Every developer knows this. And when I look to this, can't resolve the collation conflict between Latin general CIS and bin. What will you do? First effect is that, and by the way, I did it when I was developing database applications when I was young. I needed the money. I didn't say that I don't know anything about databases, but they hired me. So what was my first effect? My first effect was, come on, take the first one. So I was reading, cannot resolve the collation conflict between, this one. Okay, then I take this one. I was Googling. Okay, at that time we didn't have Google. We had Yahoo. But I was Googling, and then I say here, I changed the query to this one. Now, I take the collation of my TempDB. And now the query is running, and we are so, yeah, it takes a little bit. 2 seconds. To be honest, as a developer, in early times, I said, well, 2 seconds, fast enough. I implemented it and didn't take care about it. Today, it would be a little bit different, because here I can see what the problem is. Parallel running, 71,000 IOs. Oh my goodness. Look to the execution plan, what happens here. Oh, Yeah, we have a clustered index scan on my selection. That is okay. That was expected because we say, give me all data from my temporary table. But here is the problem. We are going into the customer orders, and here we have a filter attribute. We do not have a seek attribute. Also, we have on the order number an index. So the index in this situation is useless. Why? When we go to the execution plan, look to the warning, and you see immediately what happens. Type conversion in expression and see what happens. Convert to a varchar 10 the order number, which is then equal to the temporary table order number. The problem is the convert implicit again. You remember the second demo where I have had the wrong data types. Convert to implicit is not only for data types, it's for collations in the same way. Ooh. Here is the problem because SQL Server needed to convert the order number, which is Latin bin, to Latin general CIAS. So we have to go through all 3 million rows, make the collation a CIAS, and then we could match them. Try it the different way. I make it the bin. Please remember, again, our resources, 4 cores, 71,000 IOs. I run this query and it goes faster. We go to the execution plan, it looks completely different. Wow. Hey, what is now going on? We have again a convert implicit problem, but this time the convert implicit problem is not on the customer orders, but now it is on the temporary table. Because now the temporary table needs to convert to general bin. This is the solution, but this is not the best solution. The best solution to avoid these kind of problems is when you run or when you develop anything with access to temporary tables, do not trust on the collation. Please, strongly recommended. Excuse me. Every single time, take for string data types the collate database default into the definition. When you do this, you are so safe because nothing will happen now. When you take the database default, then it will take the collation from the database in what context you are currently in. You see, when I run this query, yep, ta-da, perfect. Here we have our select, we don't have any warning here, and look to this. This is something I want to see and what you want to see when you improve your queries. That is the solution. Check the collation of the server and of the tempdb. Use the keyword collate in your queries, but define your temporary table with the collate database default, and then you will never fail. Another alternative is the table variable, but unfortunately for this, I do not have the time. I'm 6 minutes over. That's a typical German behavior. Give me 60 minutes and I want to have 75. Table variables can be used because table variables will automatically use the collation of the user database. So that does mean for now, whoops, sorry, we are finished. Unfortunately, because it was so much fun to present this to you. Yeah. I'm finished now, and yeah, are there any questions?
There's If you have any question, this is your chance to put it on the chat. I didn't stop you because the collation issue is very common. A lot of people don't think about collation when they're creating their database or when they're doing their queries, and it's a pretty common issue. That's why I let you go on.
Yeah. So if there are not any more questions, then I will say a big thank you to all of you who have listened to me. I saw it was here 40 attendees. It is such a great pleasure for me. And I hope you enjoyed what I did. I will upload the template and the demos and the demo database in approximately 60 minutes. And then you can play around by yourself with this. Hope that a few of these things have made you think about your technique when you're doing developments in SQL Server. So thank you so much, guys. It was a pleasure, and have a very good, a healthy time, and stay tuned with SQL Saturday all over the world. Thank you, and bye-bye.
Thank you, Uwe. There's just one question. Do you have this session recorded anywhere that they can view the whole? If someone wants to see the whole session, because
Oh yeah.
I saw you skipped quite a few topics. So
Yes.
Is it anywhere out there in the internet?
Yes. All everything what is mentioned here in the slide deck. You mean if the other things are in a recording?
Yeah, if you have any recording of this
No.
session, do you have a YouTube channel or maybe your blog?
Yes, I don't have my own channel, but I have a very cool idea. You know what we do? We do a past user group for Singapore, and then I do the full stuff.
Yeah,
and then you have it as a recording, and you can have it on your website.
Yeah, definitely. We can always invite you back. Thank you very much, Uwe.
I thank you all, and have a safe time, and all the best to you to Singapore.
All right, thank you.
Bye.
Yeah, so everyone, if you haven't, the link for the evaluation for Uwe's session is on the chat if you want to submit yours. We're just gonna wait for the other attendees from the other room to go to this room before we close out the day. Thank you very much for staying with us for the whole day.